So today we're talking about midpoints and medians, specifically the characteristics of midpoints and medians within triangles and quadrilaterals. So we talk about a mid-segment. The mid-segment is a line segment that joins the midpoints of two sides of any polygon. So the example we have here is we have a triangle like this. We have a midpoint here, and we see that that's indicated by these two tick marks. So this side and this side are equal length, so that is exactly in the middle of this line. And then on the other side of the triangle here, we have those two indicators that both this side and that side are the same in terms of distance. So the mid segment is right here indicated by L. So it goes from the midpoint of one side to the midpoint of the other. A mid-segment of a triangle is parallel to the third side. So this is our mid-segment. That third side of our triangle is right here. So this line, this mid-segment, is always parallel to that third side of the triangle. It is also half as long as the third side. So the mid-segment is always half of the third side. So the third side can be indicated by 2L, the 2 times the length, and our mid segment is given to us in just 1 length. The height of a triangle formed by joining the midpoints of two sides, this right here, the height of the triangle formed by joining the midpoints of two sides of a triangle is half the height of the original. Half the height of the original. And it's basically the same kind of thing we just said in that second point. A median is a line segment that joins a vertex of a triangle to the midpoint of the opposite side. So we have a triangle ABC. We go from the vertex of A and it goes to the midpoint of that other side, right? So we create an equal side length here and an equal side length here. So a median divides the area of the triangle in half, directly in half, and it bisects the area. Bisecting simply means to divide into two equal parts. So this median bisects the area of the triangle. And a triangle can only have 3 medians. So there's one, this would be another from the other vertex, and that would be the other from the third vertex. Properties of quadrilaterals, the only thing that we really need to kind of remember or think about is when you connect all midpoints of a quadrilateral, you create a parallelogram. So this quadrilateral, as we can see, is not anything special in particular, but you take the midpoint, 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 and connect them all, we create a parallelogram. So that would be a property of quadrilateral when it comes to midpoints specifically. Okay, so how this would kind of work out in terms of if we see questions or how we kind of use this information to solve for anything, we have this 2 examples here. So consider this right triangle. All right, line segment XY connects the midpoints of PQ and PR. So PQ there's the midpoint, and PR, and there's that midpoint. What is the length of XY? Well, we know that the median, the mid segment is exactly half of the other length. So I could simply write this as the length of XY is equal to, well, the one piece of information that we do know that's applicable is the distance from Q and R, 15.6. Well, we know that 15.6 is double the length of the mid segment here. So I would just simply write 15.6 divided by 2, because it's half the length. And I end up getting a length value of 7.8. This is measured in meters, right? So if we just quickly scan back up, we talked about that mid segment is parallel to the third side. It is half as long as the third side. So this is parallel to the third side. We also know it's half as long. So take that third side divided by 2, we get our length of our mid segment. Second example, The frame of the roof of a small house is being constructed. The roof consists of 4 isosceles triangles as shown. 1, 2, 3, 4. Okay, cool. What is the total length of the 3 sides that form the center or the shaded area? So we need to know the total length of the 3 sides. So this length and this length and this length put together, right? Or the perimeter of this small triangle that we find in the middle. Well, one thing we can do is a piece of information that's important, I'll go green here, would be 7.4. So 7.4 we know is the distance from one end to the other. If we take 7.4 and we divide it into 2, we would get the distance from the midpoint to one end and the midpoint to the other. So if I take 7.4, my first step, 7.4 divided by 2, it's going to give me a value of 3.6. So what that means is that this is 3.6. Now, if we quickly glance around, we notice that, oh, if that's 3.6, this is 3.6, that's 3.6, 3.6, 3.6, right? Because they're all indicated by the same tick mark. So we can take from that this side length is the same as this, which is the same as this, and all the other ones that have one singular tick mark on them. So that's the first step. Second step, the other piece of information we know is we have the base of this big triangle is 12.2. So we would need to determine what the length from one end to the midpoint and the other end to the midpoint. And we figure that out by dividing it by 2. So, blue here. Step number 2, I'm going to take 12.2, divide that by 2, and I'm going to get a value of 6.1. So that means 6.1 is this, 6.1 is that as well. So my third and final step, well, if I look at the shaded triangle area, I have this distance and I have this distance. Well, I know these two distances. These are both 3.6. So if I take 3.6 and then multiply it by 2, 3.6 times 2, I'm going to get a value of 7.2. So now I know that this side and this side is 7.2, and I have the one final outstanding piece. Well, I know that this is going to be 6.1. Because if you look at this other triangle here, for example, which we determined this to be 6.1, we know that this can also be 6.1 based on the fact that we have isosceles triangle and they're all the same side lengths here. So if this side is 6.1, this side is 6.1, that would be 6.1 as well. So I'm simply going to add them together in black. So I go step 3 plus step 2 is going to give me, well, 7.2 plus 6.1, which gives me a value of 13.3 meters. So the perimeter, or the total length of the 3 sides, is 13.3. Of 3 sides is 13.3 meters, just like that, right? So big takeaways would be what we're talking about here, the mid segment, right? Mid segment is half as long as the third side. A median goes from one vertex to the midpoint of the other, which creates equal distance on either side. And then how we would use that information to go ahead and solve. We would have one example using our mid segment and another example using our midpoints.